Okay, physics 30s. We're going to take a quick look here at a question that we were talking about in class. This is a Millikan's oil drop style question, and it's on page 122 of your workbooks here. The general idea of the question is that you have an oil drop, and it is being accelerated, in this case, upwards. Okay, and then you're collecting data on this experiment, and as you increase the voltage, you're getting an increase in that acceleration, which you're then graphing. And you're getting this nice straight line, which means you're going to be doing a little bit of calculus to this. Important to set yourself up with the conditions. So hopefully you can recognize that as a free body diagram, since all of these are accelerating upwards, then you have a free body diagram like this, where this is the force electric and this is the force of gravity. Force of gravity is a factor because, of course, it's an oil drop, and therefore we do have to think about this Fg. As a condition then, we can say that the F net is equal to the dominant force minus the less dominant force, so Fe minus Fg. And this is going to become, of course, Ma, that's because F net's always become Ma as a result of Newton's second law, and Fe is going to become our Eq, which is from our formula, and of course this is going to become mg. Okay, furthermore, since we're dealing with voltage, and I think we're given a mass, where we're told that the mass of the oil drop is 6.1 times 10 to the negative 16 kilograms. We are going to be dealing with voltage and distance, I believe. Yeah, we're given a distance, a separation distance of 6 centimeters, or 0.06 meters. So we're dealing with a voltage and a distance. So we're going to this is going to become a VQ. Oh, sorry, a V over D. So the E becomes a V over D. Okay, hopefully that's clear. The Q still stays there, and then you've got your minus mg as well. Okay, so that's getting our condition ready. This is the bit where I set up the conditions of the experiment based on the forces, based on the F nets, based on what those forces are. But the crux of this question is to do with the slope. Okay, so I've got a slope based on my straight line graph, and if I plug the numbers in, and you can do this differently, but I get a value of 0.0475, and my units here are going to be meters per second squared over voltage. Okay, but we're not too interested in the units at this moment. We just got this value. Okay, the other thing to note is that this, of course, is a y is equal to mx plus b shape, and my y is a. So hopefully you can see that I want to turn this bit of my formula into just the a. So this is going to be, I'm going to write it in, y is mx plus b, and I'm going to try and overlay these on each other. So a is already in place, that's key, I've got that there. I'm going to use red here to show you this. The a is there, that's my y, right? That makes sense, hopefully. And then I'm looking for the x, which is going to be PD, which is voltage. So the x is just voltage. So see if I can tease this out. Well, the voltage is there, so let me just put my Q here, and that's going to be over D, and then somehow I've got my plus B in there as well. Now, I've forgotten about this M. This M is going to need to be divided, so this is going to come underneath over here, and also underneath my mg, which, of course, cancels out. So if I keep following this down, I think I'm nearly there. I'm nearly there at the point where I can separate these out. So I've got A is my y. I'm happy with that. The voltage is my x, which leaves my m here. And then my b is negative g. Okay, so what I've done here is just overlaid my condition with the shape of the graph that I'm looking for, which is y is equal to mx plus b. And now we can make a statement. We can say, I'm just going to make some space in the middle, we can say that the slope is equal to this m, right? This is the slope. And my m is q over dm. So my slope is q over dm. Okay? So this question, remember, the question is actually asking to determine the charge on the oil drop. Okay, so first of all it's saying plot your graph, which we've done. Then it's saying what's the charge on the oil drop? Well, this should give me that charge since I know the slope value and I know the distance and I know the mass. So quite easy now just to rearrange this and get md slope. Okay, and if you plug that away, you're going to get a charge of 1.7385 times 10 to the negative 18 coulombs. Okay, very cool. Now, that's the charge on a single oil drop. Of course, the second part of this question you could probably predict is, if that's the charge on the oil drops, how many electrons in excess would be on that particular oil drop? Well, now we're just going to take our charge on the oil drop and divide it by the elementary charge, and that's going to give us the number of electrons, which is 10.866. Now, can you have 10.866 electrons? No, you cannot. But obviously, this is data from an experiment, so it's inherently, there's inherently error in there. So of course, we'd be rounding this up and saying approximately 11 electrons in excess. Okay, that's how you do the question. Good luck. Hopefully you can do this by yourself, and we're going to be using this process much more as we move through the course. Let me know if you have any questions, and I'll see you in class.